All right, folks, it's Bass Action, back in action here. In this video, we are going to look at area and perimeter for parallelograms and rectangles. We're going to combine our knowledge of the properties of parallelograms and rectangles, and of course our past knowledge of trigonometry and everything we know about parallel lines to fill in a whole bunch of measurements on these two figures and also be able to find the area. So let's just jump into this. Let's remind ourselves of the area formula for a parallelogram or a rectangle. We, of course, know this from our elementary and our middle school days. That formula is base times height. I want to call your attention to the fact that I'm using a lowercase b and a lowercase h. Those are going to be extremely important as we progress through the rest of this foldable. Capital B's and capital H's are going to mean something different in our world. Okay, so let's take a look at this parallelogram here. You can see I've drawn the height for this parallelogram outside the figure. We, of course, could draw it inside. It's just the distance between the two parallel lines. I've drawn it outside. It's going to just be a little cleaner for us. Let's start with this 21 here. We can, of course, fill that in as the opposite side as well, knowing that the opposite sides in a parallelogram are congruent. Now we're going to take these three angles we're given and we're going to look at how we can use those. So if our opposite sides are parallel and this is 60, we're going to visualize that Z that we've done before, and we'll be able to fill in this angle down here as 60. If this is 16, I can do my Z again and I can fill in this as 16. If this is 46, I'm going to do my Z again and I'm going to fill this in as 46. That's going to allow us to see that, of course, our opposite angles are congruent. We still need this missing angle right here. And what we're going to do is we're going to look at the property of that the consecutive angles will be supplementary. So this whole angle here and this whole angle here should be supplementary. So 16 and 46 and 60 and this missing angle should be 180. That's going to allow us to fill in a 58 degrees there. So again, back to our Z. 58 then also has to go down here, a 58. Now, the other thing that we can do is we can look at the triangles that are created here. And of course, these triangles have to add to 180. So we could fill in these angles right here and recognize that those are going to be 74 degrees. Of course, the vertical angles, it doesn't matter which triangle we work with. And then we have our remaining angles are going to be supplementary. So we can fill in this 106. Now, we won't always need those angles, but I want to remind you that these are skills that we have done before that you should be able to call on and work with at any time. Now, let's take a look at finding the area of this parallelogram. In order to find the area, we're going to need a base and a height. So I've drawn this height out here, and it's going to be perpendicular to this side right here. So these are going to be the two sides that we're going to use to find our area. Now, in order to find this height, we're going to work with this triangle that's outside, this nice right triangle, and we're going to fill in this angle, recognizing that all three of these would be supplementary. So I can fill in that last angle right there of 62 degrees, and now I can use some trigonometry to find this piece right here. Now, if I do my trigonometry, I'm going to be at 62, an opposite and adjacent is going to tell me that the tangent of 62 is going to be x over 4. That's going to give me an x value of approximately 7.5. Now, that means that when we find the area of this parallelogram, we're going to take that 7.5 and we're going to multiply it by our 21. Now, depending where you round, if you use 7.5, your area is going to be approximately 157.5. If you use the exact value carried forward from your calculator, you're going to get an area of actually 158.0. So depending where you round is going to make a difference here. The next thing that we want to do is we want to find this piece right here so that we could find the perimeter of our parallelogram. So I'm going to call that piece y. And I'm going to do some trigonometry again. This time I'm going to do the cosine of 62 is going to be 4 over y. That's going to give me a y value of approximately 8.5. That means that my opposite sides are going to be congruent, so my perimeter will now be 21 plus 21 plus 8.5 plus 8.5, and is going to give me a perimeter of 59 centimeters. So that allowed us to get both our area and our perimeter. Recognize that we started off with very little information. Now let's take a look at our rectangle here. We again want to find the area and the perimeter and fill in everything that we can. Now, what we want to remember is that all of our corners here are going to be nice right angles. So I'm going to have a right angle, and I'm going to have a right angle, and a right angle, and a right angle. We also want to recognize that each of these pieces on the diagonals are going to be congruent. So let's start filling in our angles. All four of these little angles here should be congruent, so we know each of these are 53. Again, you're not always going to write all of these in. We're just kind of doing it to emphasize in our own minds what these are. Then, of course, these are going to be complementary, so this angle right here is going to be 37 degrees. But so is this angle, and so are these other two, 37 and 37. Now, let's also go ahead and fill in the fact that all these pieces are 10. This is going to be important for us because in order for us to find the area of this parallelogram, or rectangle here, we're going to need these two sides for the base and the height. We're looking for two things that are perpendicular. Well, we know this piece here is 12, but in order to get this last side, we're going to actually work with this nice right triangle here, and we can do Pythagorean theorem. We don't even need to do trigonometry this time. So we can say our 20 squared, and then our other side is 12 squared, plus we're going to call this x squared. That's going to give us an x value of 16. So our last side is 16. Of course, that's going to make the perimeter for this nice and clean. We're going to have a 12 and a 12 and a 16 and a 16. So our perimeter is going to be 56 centimeters. And our area, I'm going to do down here, is going to be 12 times 16, which is going to give us an area of 192. And I'm sorry, I'm kind of having to squeeze this in. So our area is 192 centimeters squared. I apologize that this is kind of messy on the iPad. Oh, that should say 1, but my 1 got kind of lost there. So 192, I'm going to fix this for you. 192. Okay, so that's going to give us our area. So again, I just want you to recognize that we could fill in a lot of angles. Oh, one more thing I just remembered. We can fill in our little isosceles triangles, 53, 53. We can fill in these angles here of 74 degrees. Let's fill those in. Oops, 74. And our supplements of 106 and 106. I do want to point out that it is just a coincidence that in these two figures that the angles in the middle turned out to be the same. That does not normally happen, just was kind of a coincidence in how I created the questions.